threat intelligence report, previous incident, or even just a business use case. So let's say, for example, a sysadmin comes to us and they want to know in their environment, where are people authenticating via Azure AD without multi-factor authentication? This does happen. Cool. So we have our use case. We do our research and requirements. So do we have the logs for this? What quality are the logs in? And what detection method would we maybe apply? We move into development and testing. So what detection logic do we apply? Can you test it in staging? Can you actually validate that this actually works correctly? And then finally, you push it into production. Then with all other detections that have come before it, there are issues as usual. And that's where maintenance comes in to make sure that your detection is operating as designed. So this might be what the possible output of this looks like. I did not build this, by the way, specifically for our role. So why is maintenance neglected? Honestly, I'd imagine most people don't find it that interesting. It's in the name. Have you ever got excited about taking your car for a service or going to the dentist once a year, twice a year, depending who you are? It's just not that great. It's much better to build a detection for a new log source or new detection. And then it's not seen as a valuable use of time. Unless you have a dedicated detection engineer within your security team, you're usually in charge of threat detection response, designing security controls, and managing tooling. It just doesn't seem there's enough time, and you end up with more of a whack-a-mole approach towards it. And then some legacy teams would have maybe had a detection engineer, but they weren't liable for the alert that was generated. And that way they would develop a rule, deploy it, and then they're on to the next thing and forget about it. And even if you wanted to do all this, sometimes getting the data or metrics together to identify opportunities for maintenance is quite difficult. Okay, I'm going to say I should have put brackets, a hopefully simple, because this may turn out to be horrible for everyone. So if anybody doesn't recognize this, this is Avatar: The Last Airbender. It's one of my favorite TV shows, and a very wise man named Iroh. He's asking our detection engineer to look inwards and ask himself the big questions, like, why do we even have this rule? Which makes him furious. It's made me furious in the past as well. So, firstly, reducing the noise. There's nothing very groundbreaking here. I'm sure you've all heard it before. This is my arbitrary recommendation. If you go ahead and try and identify your top 10 detections within your organization with the highest volume, I'd say over at least a period of a month, depending on how noisy your environment is, maybe you can stretch that out. And then just prioritize further by severity. So you may have a grouping of highs, mediums, lows, and just work your way through them if possible. And then there's a number of causes behind this high rate of false positives. Usually your detection may be too broad in scope or even incorrect. You may have no context or enrichment applied. And then if anybody's ever designed a detection based on a TTP or behavioral detection, if you think of your pyramid of pain right at the top, by design, those are very noisy. And then lastly, visualizations will be really helpful here for communicating the impact of this type of work to your other stakeholders. This would hopefully aid in having this work stream prioritized in the future. So this is a really basic time series analysis of what this might look like. Hopefully you can see where the red line is kind of where we've applied a tune and your alerts just tend to decrease over time. It's really simplistic, but pretty impactful visually. So then on the flip side, we need to validate our critical and high detections. Now we want to do this because we want to make sure these are working. So some rules you may have and you've never seen fire in the entire time you've worked at your company. So you need to identify these over maybe like a 1 to 3 month period because you want to make sure these work. So again, why these might not fire? Again, maybe too narrow in scope. So if you think of an IOC rule, like a hash, for example, or the log source may be broken, which has happened on multiple occasions, or the vendor may have changed their schema and now your detection is completely invalid. And then if you want to validate that these are actually working, you need to look at some adversary emulation frameworks. So I've added a few up there, all publicly available. So you've got Atomic Red Team, Stratus Red Team, and MITRE Caldera. Okay, so in the next few slides, I'm going to go over a number of methods you can apply after you've identified detections for maintenance. Some you can apply straight away. Others would probably take a massive migration project if you're not already there. So I'm going to talk about it briefly. So if anybody has... The term detection as code has been around for a few years now, One of the earliest articles states that detection of code is a more systematic, flexible, and comprehensive approach. Oof, I'm going to need to speed up a bit. That is somewhat inspired by software development. So if you're thinking of this, you're thinking of detections stored in a repository, QA of detections via CI/CD pipeline, reliability and scalability. I've also added a second bullet point there on a very in-depth talk on detection as code I highly recommend you check out. So one of the benefits of detection as code as it relates to maintenance is version control. So if you've ever had a rule that spiked out of nowhere or just stopped completely, think of version control. If you can easily go back to a pull request or change, you can check what happened very quickly. This will reduce the time spent on these tasks massively. Context. So adding context to a detection can aid in providing a higher level of fidelity and reduce noise, which will let your analysts or engineers make decisions faster during the investigation, which is always fantastic. People tend to immediately think threat intelligence when we talk about this, so your malicious IPs, domains, etc. I'm sure you've all seen the alert about an IP in your firewall logs that was malicious about 15 years ago. So you don't just want to think that. Think asset and identity and asset tagging as well. So I've added an article by Microsoft there where they talked in depth about their impossible travel alerts, which historically used to be very noisy. Anecdotally, I can attest to this. I've closed a bunch of them off as false positives. So they changed that. And you can kind of see the image there, but basically they build up a user profile that takes metadata like your ISP, user agent, comparing authentications to previous visits. They also exclude VPNs and cloud providers. And the other part of the algorithm actually takes signals from Azure Active Directory, so your registered device information. So all this additional context lets Microsoft vastly reduce the volume of these alerts. So what is raised is highly actionable. And then adjusting severity. Sometimes all the context in the world will just not work. And that's when actually deprecating a rule or just reducing the severity is a good way to go. So in this example, which you may or may not be able to read, the user indicates that they've seen a bunch of false positives. The logs weren't that good for an investigation, so he's suggesting that we reduce the severity until an enhancement in the technology. I think it's correlation in that case can be made, which is another benefit of maintenance that sometimes when you look at these things in hindsight, you're able to tease out additional improvements to detection methods. So detection logic. This is probably the most important. So if we look back at the rule we made earlier, this is a Sigma rule that our sysadmin has now come back to us and said, oh my God, this is so noisy. Why did you ever build this for me? Can you do something? So let's try and look over some points that we can do. So if anybody here may use Duo or Okta as their identity provider at work. So they both have a default policy to enforce MFA on Microsoft 365. Now that user agent is for Windows devices that are domain joined in Azure AD, and they use the WinLogon service, which uses basic authentication. So it would get blocked by Duo or Okta. Now they do allow you to add custom user agent strings to bypass this policy. So this is something that you could exclude in this rule, and I've actually used it a couple of times, and the sheer amount of noise that's dropped off is just insane. Secondly, you may see a message. So a log may, Azure AD sign-in log may report as a single factor of authentication, but the message may read MFA requirements satisfied or skipped by. So the user already has an access token and has satisfied the MFA requirements, but it still reports as a single factor. So you don't really need to look at this specifically for this alert. And then some organizations are happy to let users have a single factor of authentication if they're coming from a trusted device or a trusted network location. These are two fields that are actually in the Azure AD log. So if you confirm with a team or your conditional access policies, you can exclude this as well. Cool. Key takeaways, and I am perfectly on time. So a rigorous maintenance process allows us to better manage the risk of false negatives while improving the efficiency of our detections and reducing toil on false positives. Getting this balance can actually be really difficult, and it will partly be based on the risk your organization is willing to tolerate. From what you've seen in the last slide, I was excluding big chunks of things. If your organization is comfortable with that, then it's all good, but maybe not. Hopefully, a small takeaway that you could actually go back to work and do. Start by identifying your top 10 highest and lowest volume detections and just try and apply some of these strategies. I think it would be very helpful. Once you can see the impact of not having to answer as many tickets, you may thank me. And then the last one is be prepared to have your work and thinking challenged. Speaking from experience here, you may have your work reviewed and there may be determined that the rule is incorrect or is of little value. That can be quite hard to hear, and it's best to look at it as an opportunity to learn. And thank you. If anybody has any questions, I'm more than happy to try and answer. And the slides, if you do want them, will be available probably today or tomorrow.
You got a question?
We're good.
If anyone has a question, stick your hand up. I'll come around with the mic. Oh. Yeah.
Oof.
Hi. There's a brief mention in there of the Sigma rule set.
Yes.
How do you find that fits in using some of the more QA type methodologies, Six Sigma and various other things, to be constantly reviewing what rules are used for, what KPIs effectively are used for?
Sorry, just so I understand that, are you asking me how you would review Sigma type rules? So admittedly, I've only used the Sigma repo a few times. The one thing I'm going to say is definitely just don't import it and start using it because it's going to blow everything up. Every rule in there is made agnostically of every single organization. If the idea was to start importing those, you want to have someone review each of them for your organization, put them in staging, just let logs run through them before you start creating alerts, because it will just blow up your sim and your team will be furious. Did that answer? Kind of? Close enough.
Time for one more, I think, Martin, if you're up for it.
Let's do it.
If we've got one.
No, I might have got you wrong, so correct me if I'm wrong. But what we've heard there is quite a good illustration of reducing the false positives to some greater degree. What can you do, or what can you perceive doing in terms of the false negatives? So those rules that give you a security blanket to wrap around yourself that never fire because they're actually badly written.
So I think we kind of touched this. Do you mean false negatives? So the ones that never fire, you should be trying to validate. Is that kind of covering what you're talking about? Yeah, so I think there was a slide. Sorry. Yes. So on the flip side, basically, you want to. This is a very basic model for maintenance. I think you could pick up any day. Is just take it from both sides. The most extreme sides, noisiest and no noise at all. On that no noise side, I'm sure atomic red team is something most people are somewhat aware of. If they're not, it's a really cool framework that lets you validate different types of attack on the. Almost forgot what MITRE attack was there, which is embarrassing for me. It'll help, hopefully, that you sort of validate these rules that never fire. Of course, there's always going to be a risk of false negatives, but this should sort of help tackle that problem. Is that kind of what you were gunning for? Cool. We're good?
Thank you, Martin.
Awesome.
Thank you, everyone. Awesome. And that one is for you.
Thank you very much.
Sorry about that. You were perfect timing. I thought you were going to put...
No,
I never really know.
Sped me up. I did too. Kind of what you were gunning for?
Really
cool. We're good?
Thank you, Martin.
Awesome.
Thank you, everyone.